This is Sai Jushant from ECEC. I am from ECE department. My roll number 24BQ1A04G5. Today's my seminar topic is multiplexers and demultiplexers. Multiplexer is a combination logic component that has several inputs and only one output. In the multiplexer is also called as mux. Mux directs one of the inputs to its outputs line by using a control bit word to its select lines. So multiplexer is also called a selector, data selector. It selects the input data values and we get the output value based on the selected inputs. So it is also called as a data selector. At any instant of time, one of the input multiplexer is selected. That is called selected input. The selected input reaches to the output. Okay. Multiplexer contains the following things: 2 power n data inputs. The input of the multiplexer is 2 power n. N is the selection inputs. A single input. N there are many inputs, but output is only one based on the selection inputs. The multiplexer sometimes is also called a data selector because of it selects the data inputs. The multiplexer acts as a electronic switch that select one from different. A multiplexer may have enable in-out to control the operation of the logic circuit. There are many types of the multiplexers. One of the multiplexer is 4x1 mux, and another one is 8x1 mux. Another one is 2x1 mux. There are many multiplexers in a combination logic circuit. The logic circuit of the logic diagram of the multiplexer is there are 2 power n inputs, n selection inputs, one output. Okay. 4x1 mux or 4-to-1 multiplexer. 4 data input mux. There are 4 input values and 2 selection inputs. Okay, formula 2 power n is the selection inputs, n is the 2 power n is the data inputs, n is the selection inputs, one output value. In the above multiplexer, P0, P1, P2, P3 are the inputs of the multiplexer. S1, S0 are the selection inputs. We get the S dash, S0 is the outputs of the multiplexer. Okay. If S1 equal to 0 and S0 equal to 0, we get output as a P0. If S1 equal to 0, S0 equal to 1, we get output as the P1. If S1 equal to 1, S0 equal to 0, output value is P2. The S1 equal to 1, S0 equal to 1 is the output. If the output value is P3. Based on the selection inputs, the outputs are changes. The output values are changing. We get the total output equation of the multiplexer by using the output equations. Therefore, F equal to S1 S0 bar P0 plus S1 S0 P1 plus S1 S0 bar P2 plus S1 S2 P3. The multiplexer implementation using logic diagram. Using here the AND gates are more. It was the one SOP form. Yet let us take the inputs of the P0, P1, P2, P3 and the complements of the inputs also. S1 bar, S2 S0 bar, S0. By connecting the total output of the output equation, we get the logic diagram of the multiplexer. For the right side one is the 4x1 mux module digital element. Okay. Next question is 8x1 mux. Design of a 8x1 multiplexer. X1, X2 are the two output lines of the 4x1 mux. X1 equal to S1 S0 bar P1 plus S1 bar S0 P1 plus S1 S0 bar P2 plus S1 S2 bar P2. Similarly for X2 also. We can construct the 8x1 mux by using the two ways. Directly we taken the 2 power 3 inputs and 3 selection inputs, one output. or we can consider the two 4 by 1 multiplexers, two 4 by 1 multiplexers to implement the 8 by 1 mux. Here the two 4 by, let us take a 2 4 by 1 mux multiplexers to form a 8 by 1 multiplexer. These two are the 4 by 1 two 4 by 1 multiplexers, and with the inputs P0, P1, P2, P3 and S0, S1 are selection inputs, and X1 and X2 are the outputs of the 4 by 1 multiplexer. We can construct the 8 by 1 multiplexer by using a 4 by 1 multiplexer, or directly taking the 2 power 3 inputs and 3 selection inputs and 1 output. In the case of two 4 by 1 multiplexers construction of 8 by 1 multiplexer, two selection inputs are there, but the another selection input is connected to the other multiplexer. In the construction of 8 by 1 multiplexer using 4 by 1 multiplexers, two 4 by 1 multiplexers are required, and one 2 by 1 multiplexer are required. The two outputs of the 4 by 1 multiplexers are connected to one 2 by 1 inputs of the 2 by 1 multiplexers. Here two selection inputs are selected at the 4 by 1 multiplexer. The another selection input is selected at the 2 by 1 multiplexer. The three selection inputs are satisfied in the 8 by 1 multiplexer construction. Okay, let us observe the circuit here. There are two selection input for two 4 by 1 multiplexers. Multiplexer 1 and multiplexer 2 are the 4 by 1 multiplexers with four input values and two selection inputs. Two selection in S0 and S1 both are connected to two multiplexers. The output of the multiplexer 1 and multiplexer 2 are connected to multiplexer 3. The multiplexer 3 is the 2 by 1 multiplexer with two inputs and one selection input with one output. Okay. The logic diagram of the 8 by 1 multiplexer is as similar as the 4 by 1 multiplexer, taking the input values S0, S1, S2, and the output equations, and write the output equations I0, I1, I2, I3 upon to I7, because there are three selection inputs. The possible cases are 8 values, 0 to 8 values of input values. Okay. The output equations are the output equation F is depending upon the input values and the selection inputs. The logic diagram of the form of the 8 by 1 multiplexer output equation is SOP form, because AND gates are connected to OR gates. Finally, the OR gates are connected to the final OR gate is output value of the multiplexer. Next concept is demultiplexer. The demultiplexer is a combination. It is also a combination logic circuit that performs reverse operation of the multiplexer. Here one input is taken and the selected inputs are taken. The outputs are 2 power n. It was the reverse operation. It was the reverse operation of a multiplexer. It was the similar to the multiplexer also. The multiplexer and demultiplexers are reverse operations. Okay, the input value is 1. The input, let us take an input as x and the selection inputs S1, S0. The output values are P0, P1, P3. By selecting the input x value is selecting the S0 and S1. In the same way in the multiplexer, the selection inputs are selected. The inputs by getting the output values. Here also same. The selection inputs are selected, the inputs in different situations to get the output values. Okay, this was the demultiplexer of 1 by 4. Here, in the above situation, we discussed the 4 by 1 mux, 4 by 1 multiplexer, 4 by 2 multiplexer. In this 1 by 4 multiplexer, logic diagram. Okay. In the demultiplexer, we can implement the 1 by 4 mux using two 1 by 2 multiplexers. Two 1 by 2 multiplexers by connecting the two multiplexers of the selection inputs. Okay. In the demultiplexer, the input values are, the selection inputs are S1 and S0. The input value is x and the outputs are P1, P2, P3. In the same way, the logic diagram of the D1 by 4 multiplexer is X is the input value, and P0, P1, P2, P3 are the output values of the input. S0, S1, S0 is the input values. By similarly for the, it was one of the similar concept for the multiplexer. We can implement the higher order multiplexers using lower order multiplexers. The 8 by 1 multiplexer using 2 4 by 1 multiplexer and 1 by 2 multiplexer, and 4 by 1 multiplexer with 2 by 2 multiplexers, 16 by 1 multiplexer with 2 multiplexers, and 2 by 1, 4 by 1, 8 by 1 also. The demultiplexer is also called a data distributor and also a series parallel converter. Okay, thank you for